Okay, we're moving on to section 9.2, part 1. And in this section, we're going to be talking about hyperbolas. So the definition of a hyperbola is the set of all points Q, so see Q here on our hyperbola, Q, for which the absolute value of the difference of the two distances, these two foci points, so they're saying if you take the absolute value of the difference of these two lines, they'll always be the same, and they will equal some value k. No matter where you're at on these lines, the distance from any point on your hyperbola to the focus points, subtract those two distances, they will always be the same. So that's your definition of a hyperbola. The transverse axis is the axis, so right here, where the focus points are both going to be on the transverse axis. So in this one right here, your x-axis is the transverse axis. And then over here, your y-axis is the transverse axis. Okay, the vertices. The vertices are the points that cross through the transverse axis and the hyperbola. So where the hyperbola crosses through the transverse axis, the branches are the actual hyperbola. So there's two branches in a hyperbola. And then this down here says asymptotes. The asymptotes are the points that get closer and closer, and they're the lines that go through the center and then get closer and closer and closer to your hyperbola branch points. So we use these asymptotes to get a really good idea of what our hyperbola branches each look like. Okay, so here is a good picture with everything drawn out. The red dashed lines, those are our asymptotes. Our asymptotes go through the center. We also have this box inside of here that helps us to draw a really good diagram of our asymptotes and also the hyperbola itself. So this box actually is this distance here, the height, that's going to be your your A value. So this is going to be the distance A right here. And then this is going to be your distance B. So this box is really nice to draw out with just a dashed line every time you have to draw a hyperbola, because then when you know what your center is, you know what your B and your A values are, you can very easily write the equation for your asymptotes, because you can see that the slope of this asymptote right here, if we wanted to write an equation for that, we would say y is equal to A, because it rises A, runs B. So our slope is A over bx plus, well, it's always going to go through the center, which this time just happens to be at 0, 0. The other asymptote would have the same slope, just negative. And so it's going to be negative A over bx. So the asymptotes for this type of an equation are going to equal plus or minus A over bx. A over bx. Alright, so here is a table that shows all of the different information for the hyperbola compared to what we had when we looked at the ellipse. So first of all, what I want you to notice is the setup is a lot like the ellipse, but the difference is that there's a minus sign in between the two terms on the left-hand side. So we've got a minus here instead of a plus. Also, I want you to notice that if our transverse axis is parallel to the x-axis, so in this first one, our transverse axis is parallel to the x-axis, so that means that our x squared comes first. Opposite here, if our transverse axis was parallel to the y-axis, then our y squared comes first. And then just notice that A is always, the distance A is always on your transverse axis. Okay, so no matter if it's on the y-axis or on the x-axis, A is always on the transverse. So then your vertices, foci, everything is the same. On this one, I'd like you to use the equation a squared, a squared plus b squared equals c squared. Okay. Also, notice that on these, see where your focus point is? Your focus point is now actually the longest distance. That's why the a squared plus the b squared equals the c squared, because your focus point is the farthest distance from the center. Your transverse axis and the other axis here, the negative b to 0, it doesn't matter if b or a is greater than or less than. So a is not always going to be greater than b in this case. But we'll always just add them together. So we'll have the a squared plus b squared equals c squared. And then your asymptotes, just like we talked about here, if this was a horizontal ellipse or hyperbola and opened to the left and right, your x-axis is your transverse axis. Then you're going to have plus or minus b over a for your slope. So y equals plus or minus b over a. Notice all of these are centered at 0, 0. So all the information on this table is only for hyperbolas that are centered at 0, 0. So, and for this homework assignment, that's all you'll get. Next homework assignment, we'll go over a little bit more what happens when our center is not at 0, 0. Okay. Okay, let's move on and let's look at some examples. Okay, example number 1, we are just doing some matching. So let's just first of all look at our equations and write out what we know. So in this one, our center is at 3, 2. And so let's look and see which ones of these would work for 3, 2. This is 3, negative 2, so that's not going to work. This one does have a center at 3, 2. But this one also has a center at 3, 2. So let's look at the difference between each one of these. Where the transverse axis is what's going to make the difference. So in this first one, our x squared comes first. So that means that our transverse axis is parallel to the x-axis. So that means that's going to be where our vertices touch the transverse axis and also our foci points also touch that transverse axis. So it's going to be this one here. So let's say A and A. Those two match. Okay. Now our next one, our center is also, so you've got to be careful. Don't always just take that first one. You've got to match up your x values. So x is 3, y is 2 for our center. So at the point 3, 2, but on our second one, the y squared came first. So that means that our transverse axis is parallel to the y-axis. And so let's leave with this and this. Then for our last one, we need to do a little bit of algebra here to solve. So we're going to subtract this x minus 3 over 1. So let's just make that a minus sign. Make this an equal sign. Okay, now we've got them how we want them. And then this is going to be a center of 3, negative 2 this time. And there's only one with the center of 3, negative 2. So match those up. Okay, let's move on to our next one. Okay, example number 2. Find the vertices and asymptotes of y squared over 49 minus x squared over 25 equals 1. So let's just start off with writing everything that we can think of that we know about this. First thing that I like to look at is our center. So the center for this one is 0, 0. Okay, let's see. So A is always our first value. So in this case, we have A equals 7. Now, what is above the A is also very important because it tells me which direction my hyperbola is going to open. So the y squared comes first. That means that it's going to open up and down. So it's going to open up and down like this. Okay. And we also know that A equals 7. We know that B equals 5. Okay, the 7 is going to have to do with the vertices. So that's the first thing that it asks. List the coordinates of the vertices. So the vertices are going to be 7 units up, 7 units up and 7 units down from our center. So that is going to change our y values. So our center was at 0, 0. Now we're going to move up and down 7 units from our center in the y direction. So that's going to change our y values. So near 0, negative 7 and 0, 7 are going to be the vertices. Okay, then we want to write the equation of the asymptote with positive slope. So that means they only want one of our asymptotes on this one. So if it is opening up and down, the a value, let me draw this, when we, this is called a rectangle guide. So, oops, we're not ready for that yet. So we open up and down here, and then we would have our rectangle guide here. So our center is here at 0, 0. Then we went up 7 units. So here in purple, we went up 7 units, and then this other direction to the right, that's our b value, and in this case, b is 5. So to find our slope for our asymptotes is going to go right through the points of this rectangle guide that we used to draw our hyperbolas. So this slope, we went up 7, to the right, 5. So our slope is 7 over 5x. Since our center is at 0, 0, we don't have to worry about the b. The b value would be just plus 0. So y equals 7/5 x is the positive slope for the asymptote of this hyperbola. Okay, example number 3. We want to identify the vertices and foci of the hyperbola with this equation. So let's first start off saying everything that we do know. We know that our center is at 0, 0. I've got a little more room on this one. So our center is at 0, 0. Okay. We know that A equals 6. We know B equals, that equals 36, because it's 36 squared. So A equals 36, B equals 27. We also know that this is a vertical hyperbola, meaning that it does open up and down again. Okay, so that's going to be the shape of our hyperbola. So our rise is always going to be what's under the y value. Oh, we don't have to find our hyperbola. So, okay, vertices is what we're looking for. So our vertices, we're going to start at 0, 0, and then we're going to go up 36 points and down 36 points. And that's going to change our y values from the center. So if our center was at 0, 0, then our vertices are going to be 0, negative 36, because we had to go 36 units in the y direction to get to the vertice, and then 0, positive 36 for the other vertice, if our center was at 0, 0, which in this case it is. Okay. The foci is going to be also on that transverse axis, which in this case is changing our y values through here. But we need to know what C is. So we've got to find what C equals. Well, we can use our regular Pythagorean identity or theorem for this. So a squared plus b squared equals c squared for the hyperbolas. And we know that a is 36 squared plus 27 squared equals c squared. I'm going to pause and calculate that real quick because I've only got a few seconds left. Okay, so I get c equals 45 for that one. So that makes my focus points be 0, negative 45, and 0, positive 45. It's changing my y values because my transverse axis is the y-axis, and so it's also going to change our y points to find both our foci and our vertices.